So this is the case right here. This is the case that I'm talking about, whereby you are only given two views and then you are required to produce the last view. So in this case, you are given the front and the right view. This thing is in third angle. You can only tell by what? By that projection symbol that they've planted for you there. This is a projection symbol for what? For a third angle. And then the top is going to be at the top. But now there's no top there, which is exactly why you are here. They need you to produce the what? The top view. So now what you have to do is you're gonna have to combine these two parts together, produce a 3D object of this part. Combine these two views to make a one full object, a one complete real object using your imagination. And then once you figure out that object, what you do, you produce the top view. Because from the imagination you're gonna get an idea of what does the top view look like. So if you cannot get the clear idea, if you can imagine it to the fullest point whereby you can be able to see, to project everything, don't worry, because the construction lines are there. You're gonna project each and every dimension that is within these two views. So now in this case, given something like this, you have your Cartesian plane already right there, because you know we are dealing with orthographic projections. And it's a third angle, which means a single view at the top and two views at the bottom. So we have the front there, at the bottom you have the right view there, and then you're gonna have the top up there on the first quadrant. So now what you do in this case, you copy and paste. You take these two views as they are, given the scale is 1:1. You take these two views as they are, you place the front there, you place the what? The right view there. So you have the corner, the top right corner, where your front should start. You go to your question, the top right corner, where is it? This is the front view. Some of you will say that is the top right corner. Well, yes, it is the top right corner as a given view, but for the whole component, the top right corner for this component is not that corner. It's somewhere there. If you can extend this horizontal line and then from this corner right here, push this vertical, it's gonna meet with that horizontal that you extended. Somewhere there, that is gonna be your what? It's gonna be your top right corner for the whole view. That is how you do this thing. Because if you're gonna say this is your top right corner and then you start drawing from there, yes, you're gonna go down by how many units? By 50 units, and then you're gonna have to produce this part, and then you use that as your top right corner. Where is the part gonna go now? Because you can see that the part is further from that top right corner of yours that you selected. So which means this part is gonna be stuck in there in between the lines, and already that is wrong. So make sure that you don't make this mistake. So the top right corner, it's somewhere there. Given that the lines are straight, that is your top right corner right there. That is the very same corner that you're gonna start from. You're gonna start counting from. This is the corner. And then now you shift to what? To your side view, which is your right view. Now your right view doesn't have any angles. This one has angles, something like ES. That is why it was complicating things. Whereby we have to find our starting point. But we figured it out. Now you shift to what? To your side view. We have the top left corner for the right view. It's the top left corner. We have the top left corner right there. So everything is perfect as it is. So now you copy and paste your views, and then from there you start paying attention, because that's whereby I'll be explaining what to do from there. So there you go. We have our views copied and pasted on your answer sheet right now. You took everything as it is, you placed it on your answer sheet. You see, there is that corner that I was telling you about. That corner right there. You see how we didn't use that corner? Because if we use that corner, this thing was gonna shift to there, and then this ear was going to interfere with our view. So you always extend the corners if you have something that has an opening, has a space like that. So what do they need from us here? There is an empty space for the top view there. Supposed to put a top view up there. The next thing that you do is you produce a 45-degree line that starts from where? From this corner, from the top right corner of the front view, and it goes to that direction. It makes an angle of 45 with what? With the horizontal. So there is your starting point, the top right corner. our special corner, you take a 45-degree, just like that. So there you have your 45-degree line completed in faint line there. You do what you know. You have to project each and every marked dimension from each view to what? To the direction whereby you're supposed to put your top view. So every dimension from the front view, they should go and invade the space where you are supposed to put your top view. So let's go ahead and do that. All right, then now you are done. You are done projecting all dimensions from the front view to the top side. So now the next thing you do, your side view should also do the same. But now, how do you get your dimensions from the right view to that area over there? So same thing applies. You project all the dimensions from the side. But now, how do you do that? Now, that's where our 45-degree line comes in. Our 45-degree line helps with what? With projecting from the side view to the missing view. So after extending that point, after projecting to the what? To the 45-degree line, once once you touch the 45-degree line, that's where you stop. And then after stopping from the 45-degree line, it turns horizontally. It reaches your what? It reaches the destination where it's supposed to go. So now it's gonna end there. Not necessarily, it doesn't matter if it ends directly at that line. I'm just doing that for neatness purposes. So you can also pass, because you know it's a construction line. It's not a solid line. So it can pass, it can end anywhere. It has no dimension. But I'm gonna end mine there because I know that is the far end point for what? For the top view, because it's the same far end point for what? For the front view. So I'm gonna end it there. And then after doing that, you do the same thing for each and all the corners. So after doing that, you're gonna end up with something like this. After all that work, the only thing that is left for you to do is to use your brain and imagine this component as a whole. By that I mean you should put together the front view and the side view, and in your mind you should create a single component. And then after that, this mess that is happening right there, the crossing of these lines, the horizontals and the verticals, your view is already there. Since you've projected everything, your view is already there. So let's carry on and figure out our top view. So let's look at the front, because we know that from the top you're gonna see this part right there, which is the top part. But in the top view, because this we can see it from the front, in the top view is gonna be where? It's gonna be at our bottom. It's gonna be in that level right there, because that's where our top should start. So if we are using our special corners method, where our top should start, our top is supposed to start from there. Now let's go over and outline what we can see and what we cannot see. You start with what is almost obvious, just like that part right there. So what are you gonna see from the top side? You should start from there, exactly from there. You should map it with the top side of the front view. So where does it go? It goes there, and then it ends where? It ends there. And then from there, you already know that there is no gap at the top of the what? At the top of the component. Where do you get that from? You get it from the side view. The side view has a straight line, because this corner right there, that corner is the same as that corner right there. This corner. So it's like, if you can fold this right hand side, you fold it inside the screen, so that it goes from this corner and that corner all the way to the back. That is how you can easily get the picture of how this thing looks like. So this corner is the same as that corner. It's the same thing. Since this is a single corner, what does that tell you? The right, it comes with proof that from that corner, that thing is straight all the way to the end. And then where is the end point? It goes, travels to the 45, and it's there, right there. And then it passes to the second level. And then how do you figure out the second level? You figure it out using the front line. So these two views now, they are helping each other to come up with the top view, to produce the missing view. To the far end, and then it goes back all the way to where it started. So now you are done with the scalp of the component. This is the top part of the component. It's in a rectangular shape. So now the next thing that you do, if you're standing from the top side, this front is already telling you that after seeing this, what else are you gonna see? These ears, you're gonna see these ears right there. You're gonna see that, and you're gonna see that, and you're gonna see that, but you're gonna see it from the top view. You're not gonna see triangles like this. You're gonna look at it from the top side. So if you look at it from the side view, how does it appear? This corner right there, all right, this short line right there, the side view tells you that those things, they are rectangular shaped from where? From the side. And then this angled line right there is that part. The side view tells you that you do have a part that is shaped like this in the component. But how many are those parts? There is two of those parts. From the front view, they are shaped like this. So now, where are these parts? Let's start mapping from the side view. The first line, it's there. Touches the 45, it turns. This right there is the border of your what? Of your top view. So it starts from there to where? To exactly the vertical. So you make the very same part from the front. When you look at it from the front, and then from the side view, you make the very same part speak the same language using the lines. So where does it start? It starts there. This is the part. That part is the same as this part right there. So where does it start? It starts at this level right there. It started that level. But now you were gonna draw it from that level going upside. But now you cannot draw it from that level because the side view is telling you that that thing doesn't start exactly at the starting point, my friend. But where does it start? It starts 10 units inside. So now you shift 10 units inside, following that area right there. And then where is it actually? It's right there. It starts there. And then now you are done using the evidence from what? From the front view. You continue with the evidence from the side view. The side view, it tells you what the thickness of that thing. How thick is it? It's 20 units thick. You follow the line, you mark. And then the side view is still communicating with you. It's like, wait, there's still something, there's still more where that came from. There is another same component, just like the one that you just produced there. So where is it? There is it, right there. The reason why this thing is divided into two parts like this is because that tiny rectangular shape right there is the corner. It is that corner. The distance from there to there is the distance from there to there. When you are looking at this thing from where? From the right view. That is what you see. The side view is telling you that how does this thing look when you go around and look at it from the right hand side. How does it look? It looks like this. So hence it's producing evidence that there is more to where this thing came from. There is two of those parts right there. Actually, we call those webs. So there is two webs. You mark the first one, and then you mark the second one. And then after marking, you start what? You start outlining. One, it goes there, and then from there, it touches the very same line at the level whereby it touches at the front view. And then you go again, you produce the what? The second web. Now let's move to the other side. Let's deal with that web right there. So we are done with these two webs, and then we have to shift to the other side and deal with what? Those webs right now. So if you cannot see properly right there, let's go to the question. The question is telling you that, okay, it's fine. There is another web on the left hand side, right there. But how many are they on that side also? You see these hidden details right there. We call those hidden details. Why do we call them hidden details? It's because they represent something that cannot be seen from that view, but it is there within the component. But if you are looking at it from that view, you cannot see that thing. For instance, you see those dashed lines, these dashed lines that are going across right there. Those are the hidden details for what? For this hole right there. If you can place a ruler exactly at that point, at that center point of the arc, place your ruler there horizontally, it's gonna be in the same line with what? With these hidden details. These hidden details are telling you what? Are telling you that this hole is through all the component. It doesn't end within the component. So the hole is through. Alright, then the reason why we're here is to explain the hidden details for that web right there. So we have two pairs of hidden details. We have 1, 2, and then we have also 1, 2. So what does that tell you? The reason why there aren't hidden details here is because they are also web that can be seen from the right view, which is this web. But pay attention to this. You see the total height of this web, it ends there at this level, at that 50 units. But the total height of the opposite web, it goes all the way to the top side. Hence the hidden details. That is why these hidden details are continuing exactly from these right hand side webs to the top side. The reason why they're continuing and equal to this, the thickness is equal to these right hand side webs, is because they are telling you that since these webs on the right hand side are 20 millimeters thick, same thing applies for the ones at the opposite. They are also 20 millimeters thick, but the height, it goes all the way up to the top of the component. So coming back to your answer sheet, you do the same thing. This is the same level for the webs. And then how many of them? There are two. So the level for the web, where does it end? It ends there. It starts from this level and it ends there. So same thing applies. How are you gonna see it when you're looking at this thing from the top side? You're gonna see it the same as the opposite webs. Right there. Same thing applies for the top one. Where is it? There it is. Because the hidden detail starts from there and they end there. They also start from there and they end there. It's still the same part, the same level. So the job is done like this. Now let's move on to what? To another part now. What is left? Now, is there anything that you can see from the top view when you are looking at this thing from the top? No, there's nothing else that you can see. That right there, my friend, is exactly that thing. This one right there, it's exactly that one. And then you shift to the opposite side. This slanted line right there, this angled line right there, you're gonna see it like that. It's gonna appear as a square or a rectangle if the sides are not equal. But this is how you're gonna see it when you are looking at it from the top, from that T alphabet. And then on the top side, you're gonna see the scalp. That is the scalp. It's just a one smooth surface, rectangular surface. How do you know that is a rectangular? Because this side is not equals to that side, and you use those two sides to come up with what? With that shape right there. So that is how you come up with what? With a missing view. All right, now then there is a case of hidden details. Now the instruction comes at the question. They will tell you at the end of the question that show all hidden details or do not show hidden details, or maybe they will say show 4 or 3 hidden details. It's up to the examiner. What are the hidden details? As I explained before, the hidden details are something that you cannot see, but that is there within the part, but you cannot see when you are looking at that part from a certain view. So if you're looking at the part from the top view, what can't you see? You can see Yes. You can see the scalp? Yes. You can see that? Yes. So, what can you not see? There is that hole over there. This hole right there. You cannot see that hole, right? But it is there within the component, but you cannot see it. So, that's where the hidden details come in now. The hole is inside the component when you are looking at this thing from what? From the top view. Where does the hole start? It starts from there. It ends where? It ends there. So, this point was projected, it is there. But how far does it go? There is the hidden detail for what? For the hole. It goes all the way through. So same thing applies. How are you gonna see it from the top side? You're gonna see it as it goes all the way through. Same thing applies for the other side of the semicircled hole. It goes all the way through. Where is the proof that it goes all the way through? Where do you get the proof of that? You get it from there. Here you get the shape of it, and then there you get what? The deepness of it or the depth of it. This is how you produce a missing view. It doesn't matter if it's a third angle or it's a first angle, there's nothing different. You apply the same skills that I've taught you right here. If it was in first angle orthographic projection, you already know that in first angle you have two views at the top, whereby those two views is what and what? It's a left view and what? And a front view. So let's say this was the first angle now. So now you know in a first angle, you're gonna have this right there in your first angle, which is the level for what? For for the top view. In the first angle, the top view is gonna start from what? From that corner. You have your front up there, and then you have a left view up there. So I'm doing this because I'm trying to show you where your 45 is going to start when you are doing what? This thing in a first angle. Your 45 is gonna start exactly at that corner right there. It's gonna start where the front started, the special corner of the front view, the starting point of the front view, going downwards at an angle of 45 degrees to the horizontal. 45 degrees to the horizontal right there. This is how you were going to do it. And then what you were going to do, you transfer this point right there, it goes that way. It goes to the 45, it goes that way. Goes straight down to the 45, it goes that way. Goes straight down to the 45, it goes that way. When you are done with that, you come to the front. They go straight down. They go straight down from the front. And then you produce your what? Your top view from that position right there. Because that is where it was going to be stationed if this thing was in first angle orthographic projection, but now it's in what? It's in third. So since it's in third angle orthographic projection, it's gonna be like this. So ladies and gentlemen, this is how you deal with the first angle or a third angle orthographic projection. Given the isometric view, you know how to peel the parts from an isometric view. You know how to peel the parts, and then whereby they try to complicate things and give you two views and then one missing view. You have to apply the skills that I've just shown you here.